Modern architecture is increasingly defined by unbroken surfaces, entire walls of handleless, flat-panel cabinetry that seem to merge directly into the structure of the room. Achieving this look requires a significant mechanical trade-off. We expect heavy wooden panels to move fluidly without a visible external fulcrum or any obvious hardware to support the weight of the wood. This minimalistic aesthetic depends entirely on the concealed hinge, a device capable of sub-millimeter precision that operates completely out of sight. It is the central paradox of modern interior design. The illusion of absolute nothingness requires a massive amount of highly specialized engineering. Most people assume a hinge is simply a flat metal plate screwed onto the back of a cabinet door. In reality, installing a concealed hinge requires hollowing out the mass of the door itself. A specialized bit must bore a precise circular cavity into the wood to create an anchor point for the mechanism. This cavity houses the European hinge, an articulating arm that folds into the bored-out cup when the door is closed, keeping the hardware flush with the panel. The European aesthetic is a byproduct of this rigid mechanical system buried inside the panel. Normally, we think of a screw as a simple fastener, something to be tightened until it holds. Inside a concealed hinge, screws function as micro-navigational tools. Each rotation maneuvers the heavy wooden door across, providing independent six-way spatial control. These adjustments allow cabinet makers to define the reveal, the specific uniform gap of negative space between adjacent doors. This gap is the result of a strict algebraic calculation involving the cup distance, the base thickness, and the door's overlay. Shifting a single variable in the hardware changes the physical alignment of the cabinetry across the entire wall. Traditional hinges lack this flexibility. If the pilot holes are off by even a millimeter, the door will sit permanently crooked. A simple aesthetic is only possible because the underlying mechanism is complex enough to mathematically forgive human error. This engineering is even more critical for industrial enclosures, where heavy-duty steel doors can weigh up to 90 pounds. For these high-security cabinets, invisibility acts as armor. Concealed hinges leave no exposed parts on the exterior, making the door virtually tamper-proof. Beyond security, these hinges manage momentum. Soft-close variants use internal hydraulic dampeners to catch a swinging door and neutralize its kinetic energy before it hits the frame. Unsprung hinges use stored potential energy to do the opposite, pushing the door outward when triggered, which removes the need for physical handles entirely. This allows for a light touch on a flat surface to trigger a controlled mechanical opening. Behind the cabinet panel, a hidden spring-loaded piston executes the interaction. These internal devices substitute the physical exertion of pulling and the noise of slamming for engineered silence and kinetic triggers. In standard geometry, an open door partially blocks access to its own frame because the door's thickness occupies a portion of the opening. Swing-clear hinges use articulated arms to lift the door entirely out of the frame's footprint, providing 100% unobstructed clearance. Pivot hinges take a different approach, balancing massive weights on a single microscopic fulcrum at the top and bottom of the frame, rather than a traditional bending joint. These specialized designs allow us to overcome the standard physical and spatial constraints of an interior room. We live surrounded by these invisible miracles: kinetic dampeners, sub-millimeter spatial adjustments, and hidden armor holding up massive weights. Thousands of hours of highly precise industrial engineering lead to the quiet satisfaction of a perfectly aligned closure. The most effective engineering is the kind that removes itself from view entirely.